This lesson is for Mrs. Cucci's College Now Pre-Calculus class. Today we're going to be talking about matrices and systems of equations. This is all new material for you, and it is quite lengthy, so make sure that you have your notebook out, and an eraser is always a good idea. Use a pencil. The objective today is to be able to solve equations using matrices, so that's what we're going to start by doing. So we have to start very basic because you've never seen this before. You actually have to know what a matrix is, or a matrix is. So what we're going to do is we're going to look at this system, 2x minus 3y equals 7, and x plus 4y equals 2, and we're going to talk about how we can write this as a matrix. Okay, so it's actually quite simple. All that we're going to do here is we're going to take our coefficients in front of our variables and then our constant. Okay, so you've got a 2, you've got a negative 3, and you've got a 7, and then you have a 1, 4, and a negative 2. Okay, you're going to put square brackets and then a line for the equal sign. And what that is it's a matrix. Okay, we also call it an augmented matrix for the given system of equations because it not only contains the coefficient, but it also contains those constant terms, the 7 and the negative 2. Okay. So a rectangular array of numbers like the one above, again, is called an augmented matrix, or a matrix. The matrix above, the one we looked at, is the augmented. Okay. Because it contains not only the coefficients but the constant terms. If I wanted to look at one that wasn't augmented, we could just look at the coefficients, which were 2 and 1, and then negative 3 and 4. And that's just called a coefficient matrix. Okay. So what we're going to do is we're going to learn how to use Gaussian elimination with these matrices. And we do have some steps that we follow, and they're very similar to those steps that we did when we were doing them algebraically. We're going to interchange any two rows. We're going to multiply each entry in a row by the same non-zero constant and add non-zero multiples of one to the other. So same exact steps. Again, easier to kind of see how to do this once you actually try an example of it. Okay. So here's our first system. It is in 3 variables, and we do have 3 equations. So we've got 2x minus y plus 4z equals negative 3, x minus 2y minus 10z equals negative 6, and 3x plus 4z equals 7. We are going to start by changing this into an augmented matrix, meaning we're going to have those constant values as well. Okay, so that's how we're starting. We're going to put this into an augmented matrix. I always put the brackets around last just so I know how to fit everything. So coefficients, 2, negative 1, 4, negative 3, 1, negative 2, negative 10, negative 6, 3, and since I don't have a y, I'm putting a 0, 4, and 7. A line for my equal sign, and then my brackets. Okay, so that's the augmented matrix that I'm going to be working with. Okay, so our goal is to find a matrix that fits a different form. In that form, what I want, my goal again, is I want it to look like this. 1, A, B, C. 0, 1, D, E. 0, 0, 1, F. So the important piece to this is this right here. Okay, and then these. That's the goal. That's what we're looking to do. So we're going to have to use operations on our rows and columns. And again, just so we're clear, this is a row, this is a column. Okay, we're going to use operations in rows and columns to adjust and manipulate this so that we can fix that up and do that. Okay. All right. So the first thing we want to do is we want to work kind of from the bottom up. But in order to do that, we have to make sure that our rows are in a specific order. The first row is kind of like what we're basing everything off of, okay? We want the second and third row to be multiples of that. If we adjust this matrices the way we have it now, so that this becomes our first and then this becomes our second, it becomes, for our leading coefficients, 1, 2, 3. 2 is a multiple of 1, and 3 is a multiple of 1. That's the goal we're working towards, okay? So let's go ahead and adjust that right now. So we want 1, negative 2, negative 10, negative 6. We want 2, negative 1, 4, negative 3, and then 3, 0, 4, 7. That's the matrices we want to start with, the matrix we want to start with, okay? So we switched 1 and 2. That was our first thing. So that this first row, that first number 1, the two numbers in the rows below it were multiples of it. Okay, so remember, this here is our goal, right? So we want to try and get things to cancel out. So just like with systems of equations, when we multiplied and then added to get elimination, we're going to do that here with the rows as well, okay? So the first thing we're going to do is we're going to take a look at the first row, and we're going to multiply that through by a negative 2. The reason we're doing that is because what that's going to allow me to do is if this right here, this first one becomes a negative 2, it allows that 2 in the second row to cancel. Okay, so that's what we're going to try and do. So we're going to go ahead and we're going to multiply this first row through by negative 2. And it is going to give me a new matrix, right? Okay. So we're going to have negative 2, 4, 20, 12. And that second row stays. 2, negative 1, 4, negative 3, and then 3, 0, 4, 7. Okay, so all I did was I multiplied my first row through by negative 2. Okay. The next thing I'm going to do is I'm going to take these two and I'm going to add them. So it's row 1 plus row 2. Okay. When I go and add these together, what winds up happening is my first row, this row here, is going to revert back to its original state. So let's see what that looks like when I add row 1 and row 2 together. Okay. So I'm just going to deal with row 1 and row 2. So I'm going to put back in my third one because I didn't touch it, right? Didn't touch it. Here it is. I'm putting it back. Add row 1 and row 2. So negative 2 plus 2 is 0. 4 plus a negative 1 is 3. 20 plus 4 is 24. And then 12 plus a negative 3 gives me 9. And then my original row, my row 1, goes back to what it was. Okay, that's a 1, that's a 2. All right, so now, if you notice, we've got some zeros in there like we like. We just have to keep working towards this, okay? So, we multiplied row 1 by negative 2. Then we added together row 1 and row 2. We have to keep going. So what we're going to do next is we are going to try and get rid of this 3 right here. Let's see if we can get rid of this 3. We know we want it to be a 0, right? So what I can do is I can take and I can multiply this first row through by negative 3. So negative 3, 6, 30, 18, 0, 3, 24, 9, 3, 0, 4, 7, right? So then what am I going to do? Well, it looks like I'm going to take these two and I'm going to add row 1 and row 3. Okay, so row 1 and row 3. So when I add together row 1 and row 3, and remember that first one, the original one that I messed with, this one here, this is going to revert back. 1, -2, -10, -6. It's reverting back. We didn't do anything with the second row. We put that back. We are adding these two here now. -3 and 3 gives me my 0. 6 and 0 gives me my 6. 30 and 4 gives me my 34. And 18 and 7 gives me my 25. Okay? Again, we want that 0 there, so we're moving in the right direction. All right, so we have to keep going. Remember, we're always thinking about having that goal in mind, right? We want these 3 zeros right here, the 3 of them. Very important, those 3 zeros. We want that, okay? So we have to keep working towards it. So if we're looking at this now, it looks like the next thing I want to get rid of is that 6. So what can I do to this to get rid of that 6? Okay, so what if we take, well, look at row 2. Remember, we want it to be 1's diagonal, right? We want 1, 1, 1. We're not there yet. So let's look at that 3. What can I do to the second row to make that 3 into a 1? And you're thinking about multiplication. That's what we're working with, or adding rows, right? What if I were to take row 2 and multiply it through by a third? What would happen here? Okay, so let's actually do that. Everything else is staying the same. 1, -2, -10, -6. I'm multiplying through by a third. 0, 1, 8, 3, 0, 6, 34, 25. All right, so now we've got 2 1s, and we've got that. Now we have that 6 and that 34 we still have to work with. They got to be a 0 and a 1, so we got to keep moving. Okay? So, we got another 1. Let's talk about how we can use row 2 to fix that 6 for us. What would we have to do to row 2 to get rid of that 6 in row 3? What about if I multiplied row 2 by a -6? Okay, so again, thinking about elimination. So, what this looks like now, weird. Okay, that first row doesn't change. Second row, we're multiplying through by -6. Third row doesn't change. Remember, the row we mess with reverts back after we do what we need to do next, okay? So then it looks like I want to add these two. So row 1, never touched it. It's going to stay what it was. We're going to add. Row 2 is going to revert back because I did this to it, so it's the original. We're going to revert it back. And we're adding these two, right? We're adding these two right here. So we get 0, 0, -14, 7. All right, we're really close now, right? Now we just need to work on this -14, and we want it to be a 1. So what can I do? Remember, we can multiply through by fractional values. So what if I just take this row 3 and multiply it through by a -1/14? Would that work? Well, I think so, so let's give it a shot. All right. 1 and 2 did not change. 1, 2, -10, -6, 0, 1, 8, 3. Multiplying through by a -1/14, 0, 0, 1, -1/2. So now, do I have what I wanted? I've got my diagonal ones, and I have my 3 zeros here. I've completed what I want. So now what I do with this information is I take it and I write these as a system of equations. X plus 2y minus 10z equals negative 6, y plus 8z equals 3, and z equals negative 1/2. So we know from what we did yesterday, we can now use what I have, my three systems here, to go back in and substitute to find out what y is and find out what x is, right? So let's do that. Oops, did not mean to do that. Okay. So we know what z is. Because we have z, we can plug it back in. Y plus 8 times negative 1/2 equals 3, or y minus 4 equals 3, y equals 7. So now we have z, we have y, and we need x. Plug it back into the equation above it. X plus 2 times 7 minus 10 times a negative 1/2 equals negative 6. X plus 14 plus 5 equals negative 6. X equals 3. So what I have here is my ordered triple, right? We have my ordered triple. My ordered triple is 3, 7, negative 1/2. And there we have our solution. So that is how we use matrices to solve a system. Okay? I'm not going to start the next one. I think we will do the next one in the next video. No, that's a lot to process since it's all new information. Please make sure that you come with questions. And I know that these are long and they take up a lot of space, but the addition and the multiplication is not difficult as long as you can figure out what you need to work towards, right? So that original matrices that we showed you in the beginning, this right here, we're working towards this. Okay, those 3 1s and the 3 zeros. That's the goal. All right? Okay, so again, come in with any questions, and I will see you tomorrow.